In this film, we'll be discussing driving axle overhaul procedures. Although our vehicles use several different axles, many basic service procedures can be used on any of these axles. As we'll see shortly, driving axle service is pretty simple. Equipped with the information contained in this film, you should be able to perform all of the important procedures needed to properly overhaul a driving axle. Diagnosis procedures are covered in your technical service manual. Our vehicles utilize different driving axles. 2 are manufactured by AMC, while 3 are manufactured by the Dana Corporation. The 2 axles manufactured by AMC are referred to by their ring gear sizes, 7 and 9/16 inches and 8 and 7/8 inches. The 3 axles built by Dana are simply referred to by their model numbers, 30, 44, and 60. In this film, we'll run through a complete overhaul using an AMC manufactured 8 and 7/8 inch axle. You can tell an AMC manufactured axle from a Dana manufactured axle by the shape of the differential cover. The AMC cover is rounded, while the cover on a Dana manufactured axle has a protrusion for the ring gear stamped in it. For photographic purposes, we'll perform our overhaul with the axle removed from the vehicle. We'll begin our overhaul by disassembling an axle. When we have the axle disassembled, we'll pause and discuss pinion depth. It's important that you understand pinion depth theory before you attempt to perform a very critical service adjustment, the pinion depth adjustment. As we reassemble the axle, we'll cover this adjustment in detail, as well as several others. The pinion bearing preload adjustment, the differential bearing adjustment, the differential case run-out check, the ring and pinion gear backlash adjustment, and the axle end play adjustment. The bench chart that accompanies this film is a very important part of this training release. The chart contains information that you'll find helpful when you're servicing driving axles in the future. Complete disassembly and reassembly procedures are provided in the bench chart. The chart also contains complete instructions for performing the several adjustments we'll discuss in this film. Now let's disassemble an axle. On vehicles equipped with removable hubs, remove the retaining nut. Then remove the hub using the special puller shown here. Then remove the backing plates and outer seals, the axle shafts and inner axle shaft seals. Remove the differential cover. Mark one rear bearing cap for its location, then remove both caps. Use pry bars to remove the differential case assembly. Be sure to keep the respective carrier bearings, bearing cups, and shims together for reassembly. You may even want to attach each shim to its bearing cup with a piece of string or wire. On AMC manufactured axles, the shims are located between the bearing cups and the axle housing. But on Dana axles, the shims are positioned between the bearings and the differential case. If you will be replacing the ring and pinion gears, remove the ring gear from the differential case at this point. After you've removed the pinion nut, universal yoke, and pinion gear, remove the oil seal and pinion front bearing. Then use special tool number J21787 to remove the pinion front bearing cup from the housing. Use special tool number J21786 to remove the pinion rear bearing cup and depth shim. The pinion components are shown here: the front bearing cup, front bearing, and rear bearing cup, the oil seal, the collapsible spacer, and the pinion depth shim. You can discard the collapsible spacer and oil seal. Our driving axles utilize matched hypoid ring and pinion gear sets. In this design, the pinion gear is positioned below the ring gear centerline. This design allows the drive shaft to be placed lower in the vehicle, which results in more usable space inside the vehicle. However, this design requires that the pinion be properly positioned in relation to the ring gear. This relationship is known as the pinion depth setting. In order for the ring and pinion gear set to function properly, the pinion depth setting must be very precise. As you can see, pinion depth is the distance between the face of the pinion and the axle center line. Let's see how this precision is achieved. When the ring and pinion design is on the drawing boards, a specification for pinion depth is established. In our example here, that specification is 2.547 inches. Theoretically, this setting should provide noiseless, efficient operation. Keep in mind, though, that each axle model has its own standard pinion depth specification. Always consult the technical service manual for the correct specification. When the ring and pinion gear set is manufactured, both gears are marked with an identical number. The first number is simply a match number. The -4 here is the pinion variance number. The pinion variance number, then, provides you with an important reference you'll need when you install a new ring and pinion set or new pinion bearings. This number will help you determine exactly what shims are required to establish the correct pinion depth. We'll get back to this pinion depth adjustment momentarily. Let's assume that upon inspection of your disassembled axle, you find that you need to replace the ring and pinion set. First, be sure to check both gears of your new set to make sure that the match numbers are the same. Here's an important point. Verify that the pinion variance number is less than +9 or -9. For instance, if this number is +9, return the set to the parts department. For a complete explanation of this caution, consult your technical service manual. Now we'll run through the pinion depth adjustment procedure. So take a minute right now to remove your bench chart from the kit box. Turn to page 28, which is entitled Pinion Depth Adjustment. As we solve the problems in example 1, you'll have to fill in the blanks as we go along. The first figure we have to obtain is the standard pinion depth specification, which is listed in the technical service manual. For the 8 7/8 axle, that figure is 2.547 inches. Enter this figure in problem A of your bench chart example. Next, record the variance number of the new pinion. In our example, this number is -4, which means that we now have to subtract 4/1000 of an inch. So our desired pinion depth figure is 2.543 inches. Now you can begin reassembly by using the special tool shown here to install the pinion front bearing cup. Next, install a 100,000th pinion depth shim. Using this size starter shim will make it easy to determine your final size shim. Enter this figure in problem B of your bench chart example. Install the pinion rear bearing cup. Install the pinion. Install the rear universal yoke and the old pinion nut, but don't install a collapsible spacer. Tighten the nut to the desired bearing preload, which is 17 to 20 inch-pounds. Install the 2 discs on the arbor tool, then tighten the bearing caps into place. Install this gauge block and holding tool. Release the plunger and be sure that the plunger is contacting the center of the arbor tool. Then tighten the set screw and remove the gauge block for measurement. Measure the gauge block with a micrometer. At this point, you'll have to do some arithmetic to determine the appropriate final shim size. In our example, the measured pinion depth is 2.546 inches. As you can see, the pinion gear is too far down in the housing. Obviously, we need a bigger shim to bring the pinion gear up to the desired depth. So now we have to figure out what size shim we need. To do this, enter these figures in your example. First, record the measured depth. Then subtract the desired depth in problem C of your example. This tells us that we have to increase our shim size by 3 thousandths. So add this 3 thousandths to the original 100 thousandths in problem B. This gives us the new shim size, 103 thousandths. Sometimes you may find that the measured distance is less than your desired pinion depth. In this case, the pinion gear is too high in the housing. Here, for instance, the measured distance is 2.540 inches. This means we need a smaller shim. This second example has already been filled out for you in the bench chart. Now, when we compute our shim size, we come up with 3 thousandths again. But now, we have to subtract 3 thousandths from our 100 thousandths shim to determine the required shim size. So our new shim size is 97 thousandths. Once you've determined the correct required pinion depth shim size, slide the arbor over far enough to facilitate removal of the pinion. Remove the pinion nut and universal yoke. Remove the pinion once again. Then, with the front bearing in place, install a new oil seal as shown here. Now install a new collapsible spacer. This spacer plays an important role. As the pinion nut is tightened during final assembly, the spacer collapses. This collapsing action establishes bearing preload. After you've installed your new depth shim, install the pinion, the yoke, and a new nut. While rotating the pinion, tighten the nut only enough to remove the end play and seat the pinion bearings. Tighten the nut in small increments. Then, use a torque wrench to measure the torque required to turn the pinion gear. Remember, if you exceed 17 to 20 inch-pounds, be sure to replace the collapsible spacer and repeat the bearing preload adjustment procedure. Next, reinstall the differential case with 2 80 thousandths shims. Tighten the bearing caps finger tight. With a dial indicator in place, as shown here, pry the differential carrier to one side. Zero the indicator. Pry the carrier to the other side. At this point, you'll have to take a reading and determine what size shims are required to reduce the end play to zero. Complete instructions for performing this procedure are provided in the bench chart along with an example. When you've installed the differential bearing shims, check the differential case runout using the procedure shown here. If the runout exceeds the specification in the technical service manual, replace the differential case. If the runout is correct, install the ring gear. To adjust the backlash between the teeth of the pinion and the ring gear, use this procedure. While you move the ring gear back and forth, note the movement registered on the dial indicator. Consult the technical service manual for the proper specification. If your measurement is not within this specification, you'll need to correct this situation by changing the differential bearing shims again. After the backlash is properly adjusted, you'll have to increase your shim thickness to obtain proper preload. The reference book contains complete instructions for determining the required shim size. Next, install both inner axle seals. Install the axles and axle bearing cups. Apply sealer to the brake support assembly and axle tube flange. Then install the brake support assembly. Be sure to install the original shims that were removed from the left-hand side during disassembly. On vehicles equipped with tapered axle shafts, use the special tool shown here to check the axle end play. On flanged axles, there is no adjustment. Consult the technical service manual for the correct specification. To correct the end play, add or subtract shims behind the left brake support assembly. And that's it. Now you're ready to install the cover and add the lubricant. Remember to hang on to your bench chart, which will come in handy in the future when you're performing axle service procedures. For some real hands-on driving axle service experience, be sure to attend the AMC Jeep Service Training School on driving axles when the school is held in your area. And remember, your AMC and Jeep technical service manuals are your most complete sources of information on driving axle service.